Hello! First things first, it's essential that you've watched my video on Redshift. If you haven't, then this video won't make any sense. So let's start with the beginning of everything, the Big Bang, the theory of how the universe was created. 3.7 billion years ago, all the matter in the universe was concentrated into a single incredibly tiny point. This tiny speck was incredibly dense. After all, it contained all of the universe, and therefore was incredibly hot. Then, all of a sudden, it exploded and began expanding, and the expansion is still going on today. We think it exploded because we have noticed cosmic microwave background radiation found everywhere in the universe. Don't worry about what that means, it's just heat thought to be left over from the explosion. And we also know that in an explosion, the fastest moving objects move the furthest, just like the furthest galaxies are moving the fastest. This theory can be proven because of redshift. In case you've forgotten, redshift is when galaxies that have been producing normal wavelengths due to the helium in stars absorbing light slowly have the wavelength shifted up the spectrum to the colour red. In the picture, we see the black lines where light has been absorbed by helium, and below we see a change where the wavelengths have shifted towards the red side. Again, you can watch my video on redshift if you need my help on that, but redshift proves that the universe is expanding because of the Doppler effect, where the wavelengths get longer the further away the source is, proving that the galaxies have gotten further away. One very instrumental thing in our discoveries of the universe and how it may be created is the telescope. There are many different types of telescopes, not so good for us, but you'll have to bear with me. First of all, there are our standard optical telescopes, which have come a lot from just the pirate spyglasses. The picture I'm showing you is a 30-meter long optical telescope capable of seeing things 13 billion light years away, and will be based in Norway atop the mountain Mornaki. Now, although optical telescopes are powerful and can also be relatively cheap for amateur astronomers, they must be based in places that aren't light polluted, and that is becoming a rarity. They can also only be used at night when the weather is good. But until recently, our efforts to find redshift have been low because we've no way to measure gamma rays that were released from distant galaxies, until we realized that they heated up dust and made them glow. And now we can accurately measure redshift using the new technology in optical telescopes. Earth likes to be difficult for us because two more types of telescopes, X-ray and gamma telescopes, have their electromagnetic radiation absorbed by Earth's atmosphere. They therefore have to be launched into space so that we can measure electromagnetic radiation emitted from other galaxies. These space telescopes can observe the whole sky and work in any condition, but they are expensive to launch into space and maintain. They can also detect things that aren't blocked by dust, unlike the optical telescopes. Then there are radio telescopes that let us see unseen galaxies that are so far away that the redshift is so great that the wavelengths move into the infrared spectrum. We can use radio-astronomy, which means using radio telescopes to detect radio waves, a bit like a radio we use to listen to music on radio stations. But these radio telescopes have to be huge because radio waves are so much larger than light. Because the radio waves' wavelengths are so much larger than light waves from gamma rays and X-rays. However, even with all this new fancy technology, there is still much about the universe that we don't understand, and in fact, as we develop even fancier technology, our current theories like the Big Bang might be disproved or changed. Dark matter, which is an unknown substance said to be holding galaxies together, is thought to be the cause of the accelerated expansion of the universe, but it does not emit any electromagnetic radiation, so we have no way of telling what it is. That, and along with many other things like the big questions, is the universe infinite, and is there life on other planets, are some of the many other things we don't know. And on that note, I'm going to end this video. This has been the last chapter in the physics topic of space, and I hope you found it interesting and also useful. And I may see you again later. Goodbye.